Hi guys, and welcome to our new unit on all things moles. This particular lecture is going to focus on the basics, but before we jump in, I want you to know that moles are a huge, important, central concept in chemistry, and I know we're just now getting to it, but that's because we had to lay a lot of groundwork first. But now that we've got all of that in place, we're ready to jump in. So for today, Lecture 1 is going to be on different types of formulas and something called molar mass. We're going to spend the first few lectures kind of putting all of the pieces out there and then bringing them all together at the end. So this first lecture is very important. It's very small, specific things, and I think you're going to find them individually to be very easy, but they do require practice so you remember what they're called. So some vocabulary first. Let's start with this. We have molecular formulas. Now, some of these things we actually already know. We've learned a lot this year, but we don't always use the terminology that we should. So for this, molecular formulas, this is something that we've been doing all along. These are chemical formulas that give you the total number of each atom that is in a particular compound. Now, that sounds like something, kind of fancy, but really, when we've been writing formulas all year, like water, that's exactly what we've been doing, is giving you the formula for something and telling you exactly, what is in it, right? Just like that. Now, the thing about this is, though, technically, molecular formulas really apply to covalently bonded molecules because in a covalently bonded molecule, the formula itself is what is in the compound. It doesn't apply to everything all the time. So molecular formulas, when you use that word, you're really talking about covalent compounds, but you're also talking about specifically what is actually literally, if you could see the atoms, what is in the atom, or I'm sorry, the compound. Now that is slightly different than empirical formulas. Empirical formulas are formulas that are the smallest whole number ratio. Now, we have been using these already as well. This is mostly when you are talking about something that is ionically bonded, so your metal and your nonmetal. Remember how we made a formula so that it came out to be neutral? So like we talked about salt a lot, NaCl. NaCl is just the ratio of cations to anions in the crystal lattice that makes up a grain of salt. So you're talking about the lowest ratio. So we typically have empirical formulas, or we always have empirical formulas when we're talking about ionic compounds. We can also have empirical formulas when we have covalent compounds, but in the context of like doing things with them in lab, they wouldn't be all of that useful. They're actually more used to come up with the molecular formula, the one that's the actual formula. Sometimes, though, what we do need to do is we need to turn that molecular formula into an empirical formula, and that's what these abbreviations are. And all we have to do then is just reduce it. So the thing to remember is that the molecular formula can be thought of as the real formula, the actual formula, and the empirical formula is the lowest ratio of that formula. Now, I know that's a lot of strange words, so here's a really simple way to kind of see what's going on. Here I've got a couple of different formulas. On the left, these are all molecular formulas. So these are what's actually in the compound. But I could turn them into empirical formulas by making them the lowest ratio. So here I've got N2O4. I can divide both of those numbers by 2. And if I do that, I end up with NO2. So the molecular formula, the actual formula, is N2O4. But the lowest ratio is 1 nitrogen for every 2 oxygens. So that's really the difference. Okay. Here I have C4H10. Again, these are both even numbers, so I can divide them both by 2. And that gives me C2H5. So again, molecular formula is the big actual formula. Sometimes I like to refer to it as the fluffy formula. C4H10, and the empirical formula is the reduced down, the lean formula. Here's one from biology, C6H12O6. This is glucose. Right? We can definitely reduce that. Here I've got 6, 12, and 6. So I can divide all of those by 6, and that gives me CH2O. And then the last one here, NH3. Well, you know that this is like an invisible one. Well, there's actually nothing I can reduce this one by. So sometimes the empirical and the molecular formulas are the same. So if they can't be reduced, it doesn't mean you've done anything wrong. It just means that they're the same. Okay. So this is the first thing, is recognizing the difference between empirical and molecular formulas. So they're the types of formulas that we've had all along. We just never called them that. Okay, now we're going to take a little trip off to the side here before we come back to those formulas. So we're going to be talking about molar mass and something called the mole. Okay, so the mass of 1 mole of atoms of an element, I should say compound, is equal to the atomic mass in grams. Now, that is, again, it's another definition, but the bigger question is, that's all well and good, but what the heck is a mole, right? Well, a mole is the big important thing in chemistry. A mole is what is called a counting unit. Okay. Counting units are things that we use in our everyday life to simplify talking about a group of items. Now, you already know some counting units from everyday life. Depending on what your experiences are, you might know more or less. And you learn them when you're little, and so you just kind of accept them to be true. So here are some examples down here, right? If I said I had a dozen eggs, pretty much everybody knows that a dozen means 12. And at some point when you were a little kid, somebody told you that a dozen was 12. And you didn't question why it was 12 instead of 10 or instead of 15. You just said, oh, all right, it's 12. Well, good, it's 12. So that's a dozen, that's a counting unit. The next thing that's a counting unit is the term pair. So like if I have a pair of shoes or a pair of socks, right, it means I have 2 of those things. So having 2 things and calling it a pair is another example of an everyday counting unit. Again, I learned it when I was little. I don't wonder why it's 2. It just is what it is. Now, as a teacher, we use a lot of paper, so I know that a ream of paper is 500 sheets of paper. You might use reams for other things, but usually it's paper, as far as I know, but it's 500 sheets. Okay. Another thing that's used is something called a gross. A gross is 144 of something. Right? So if you buy a gross of something, you're buying 144. It's 12 dozens. So again, these are counting units from everyday life. Well, in chemistry, our counting unit is called the mole. It is the only counting unit in chemistry. That is why it's so very, very important. We use moles all the time to describe large groups of atoms or molecules or compounds. And we want to talk about big groups because atoms are really, really small. Okay. So a mole, right, we said a dozen is 12, a pair is 2. Well, a mole refers to something that actually has a name. It is Avogadro's number. Write it down here, Avogadro's number. And the question is, how many is in there, right? Well, the answer is a lot, actually more than a lot. It's this number, 6.02 times 10 to the 23rd. That is what a mole is talking about. So it's not 12 atoms, it's 6.02 times 10 to the 23rd. Now, the mole does have an abbreviation. It's not much of one. It's MOL, right? But the mole is what's called a SI unit, a standard unit. So just like we've got meters and grams and liters, in chemistry you have moles. And moles contains exactly 6.02 times 10 to the 23rd particles or elementary entities is what they updated the definition to in 2018. So what on earth is an elementary entity? Well, it just means it's this many of anything. It could be this many atoms. It could be this many molecules. It could be this many ions. It could be this many elephants. If you have a mole of elephants, you have 6.02 times 10 to the 23rd elephants. Okay. So before we jump into anything else, we've got here a video, and I am going to play it for you guys that are watching this from home because I'm going to play it in class too. Mr. DeWitt does a really good job of helping to explain what a mole is. So I'm not asking you to write anything down while you watch this, but I am asking that you watch it because he's going to talk about how big a mole is and relate it to some everyday things. So let's see if this works while I'm recording. I don't know if you're going to be able to hear it. Let's see. Okay, so thanks for bearing with me. I hope that worked. Those of you that are at home watching this, if it didn't work, I'm sorry. I'll figure it out. But let's go on. So that was the long part, really. So here we go. Oh, there we go. So Avogadro's number, you have this on your paper, right? If you didn't do this with him, because I told you you didn't have to write anything, you can do it now. So we're going to put this into scientific notation. Now, I don't know if you noticed, but when he wrote the number, they were kind of written in groups of threes. And you will see that I will do that as well when we have really big numbers or really small numbers with a lot of digits. And this is pretty common. And the reason that there's these spaces in between is actually to help you keep track of your numbers. So he went like this, 1, 2, 3, and that is totally a perfect way to do it. Another way that you can do this is if it's written with these weird little spaces here in between, they're always in groups of 3. I don't know why, they just are. So here we can count by threes if you prefer. So that would be 3, 6, 9, 12, 15, 18, 19, 20, 21, 22, 23, to put the decimal right here. So you can see that you can do it by groups of 3 if you would like. We will learn how to use our calculator to put the number in like this in coming lectures, but not today. Today we're just learning this is Avogadro's number, and this is equal to 1 mole in chemistry. This is our version of a dozen. Okay. So 602 hexillion, how are we going to count a number like that? Well, we don't count a number like that because truthfully, we can't count a number like that. If you started on the day you were born and you lived to be 100, you would still be dead before you were even halfway there counting to this number. That's how huge it is. So instead, in chemistry, what we do is we do something called counting by weighing. So it's an indirect way to figure out how many particles you have. So if you know how much one of something weighs, you can figure out how many you have if you have the total mass. This is kind of how you figure out how many jelly beans are in the jar for like maybe a raffle, right? So here, for example, if you're at home, you're not going to see me hold this up, but my kids have these BBs that come in like this little, I don't know, plastic jar kind of thing with a cap that they can pour the BBs out into their BB guns. Well, one of these little copper-looking BBs weighs 0.35 grams. The container weighs, I put it on my scale in the kitchen, it weighs 525 grams. So I can figure out how many BBs are in this container. And the way I would do that is I would take the total weight, right? And I would just divide it by the weight of 1. And I would be able to see how many BBs are in this little container. So then when my kids tell me that they swear they didn't shoot any BBs while I was at work making copies, I could put it on the scale and I could see if the weight went down, and I could even tell them how many times they shot the BB gun while I was gone. Of course, I'm not going to do that, but I could. Okay, so this is what we do in chemistry. We call it counting by weighing. We take the weight of our big pile, and in our case, our big pile is of atoms, and we can figure out how many we have by figuring out the weight of one little atom. All right, so what does that have to do with molar mass, which is what we started with, and the question of how do I know what a mole weighs? Well, we were getting there. We just had to slowly get there. Okay. So the mass of a mole is called the molar mass, right, as in the mole of a mass. And in order to determine the molar mass, all we have to be able to do, oh, typo, guys, all we have to be able to do is count the number of atoms that are in each element in a compound's formula. And then we're going to use our periodic table. Good news, we already know how to do this. We counted atoms when we were balancing equations. So here I have NaClO4. So I can count these, right? I have 1 sodium, I have 1 chlorine, and I have 4 oxygens. This is easy. We totally know how to do this. Over here in my aluminum carbonate, I have 2 aluminums, I have 3 carbon atoms, and I have 9 oxygen atoms. So see, You already know how to do this. This is not at all scary. I'm going to use my ability to count atoms to figure out the mass of a mole. So that's the first step. We count up the atoms. Okay? So we did that. So what we're going to do, here are the steps. You're going to count up count up the numbers, and then you're going to use your periodic table. And you're going to look up the mass on the periodic table of each of those elements. And then you're just going to round off the number to 2 decimal places. Okay? So I'm looking up copper, and I'm using the mass, the atomic mass. We've never used this number before. This is the one with decimals. And I see that it weighs, if I round it off, 63.55. And according to this formula, I have one of them, so I say times 1. And then I look up sulfur. So according to the periodic table, I have 3206, and according to the formula, I have 1. Now, oxygen on the periodic table is, I'm going to write it right here. On my periodic table, it says 15.999. I need 2 decimal places, so this rounds that up to 16.00. And according to the formula up here, I have 4 oxygens. So I looked up the elements, I counted up how many, and then I just used my calculator and I multiply out each one of these. And then 16 times 4 is 64. Okay. Now to get the molar mass, the mass of a mole, all I have to do is add these up. So when I add all of these up, I get 159.61. And my units are, that's how many grams, so G, are in 1 mole. So I put G over moles. This is the big math thing for this first lecture. Simply finding the molar mass, the mass of a mole. So the mass of Avogadro's number, 602 hexillion copper sulfate molecules would be 159.61 grams. Here are some practice problems. Now in class, we're going to do these together and then check. If you're at home, pause the video, grab your periodic table and look these up. And then once you've looked them up, then unpause it and check. So I'm going to give you a little countdown here to hit pause, and then I'm going to write in the answers. But please, please, please make sure you actually do the work so you know if you're doing them right. Okay, so go ahead and hit pause in 3, 2, 1. Okay, I hope you hit pause. I'm going to go ahead and give you the answers here. So you should be checking your answers against mine, and they should be incredibly close. Now, if you have rounded slightly differently, or maybe, now I'll tell you honestly, I'm notorious for putting everything in my calculator and not rounding off until the very end. So if you have like point over here, 166.92, and I have 9.1. Honestly, guys, it doesn't matter. We're going to talk about it in the next lecture. If this last digit is a few off from what I have, it's okay. Now, if your tenths place is off, it's probably not okay. But if you've got like 0.92 or 0.93 or even 0.89, you know, if you're within a few hundredths, you're going to be fine. Okay, so those are the ones I'm giving you the answers to. Now, here, I am not giving you these answers, but what I want you to do, and I'm not going to show it to you here on this, is I want you to attempt the problems below. These are also in your note packets. I want you to watch the little video from Mr. DeWitt. Notice it says stop at 9:09 because he does hydrates and we're not going to do hydrates. So what you can do is do these and then watch Mr. DeWitt. And that is how you can check your answers, and that's also how you will get other names for molar mass. Molar mass can be one way. That's my preferred way of talking about this number that we're looking up, but there are lots of other terms for it. So make sure that you watch Mr. DeWitt's video. I don't think that you can click on it in my YouTube video right now, so I'm going to put this particular link. Actually, I'll put them both. into Google Classroom, and I'll also put them onto our web page so you can use whichever format works best for you, but that's how you'll check your answers. So I know this one was a little long because I embedded the video. If the sound didn't work, just hop on over to Google Classroom and you can watch it there.